Good morning. How's everyone doing? Wait a second and make sure my levels are good. I got a copyright strike on my last stream, so I'm gonna try and make sure the music isn't too loud this time. But I do like having music, so luckily it's only picking up through my mic, so as long as it's not too loud, the AI shouldn't be able to detect it. So I've been working on some of the immediate mode rendering for the graphics subsystem in Gunslinger, and what I thought I'd do this stream is go over some of that, and then I want to start working on a small example project using it. So I'm thinking Pong would be the easiest thing, most straightforward. But whenever you want to start up a new Gunslinger project, this is kind of the bare bones application. So we have our main function here, is where we'll declare the application. The way you do that is that there's something called an application descriptor. So you'll create an instance of that in the global scope, and then you can give it certain hints. So like a window title, you give it the width and the height of the window that you want it to create for you. And then you have various other things you can fill out. So this init function will get called by the engine in order to initialize any application data that you need to initialize. This update function gets called every loop cycle. And then the shutdown function whenever you want to actually shut down and clean up any of your memory. Then in order to create an instance of the engine, you'll call the engine construct function, which will register a global pointer to the engine for you, and then returns that back. And then you pass in your app descriptor, which registers all this stuff for you. And then you just call run, which just runs the loop for the engine, and it kicks into all your other stuff. So during the engine construct, it'll actually reach into here and do anything that you need to do in here. And then during the run, every single frame, it'll kick into here and do all this stuff. So for our update right now, it's very simple. We're describing the platform. We're just caching the time for the platform, so how many milliseconds has passed since you started running. And then we're going to check to see if we've hit a particular key, in this case the escape key, and we're going to quit the application. And then down here, this is where we're going to do our rendering here in a little bit. But if we actually build and run this, then we just have a black screen. It's looking for input, and when we hit escape, we'll kill the application. And then we get all of our registered notifications telling us that everything cleaned up, was successful. Okay. So now there's a couple other things that we could do. So the app, if we actually go into the engine header, if we look at the app descriptor, it has this user data down here. So we can use that in order to push in any user declared data that we actually want to cache globally so that we can use any place throughout our application, right? So if you have various files and you want to share data, you could dump some global data into that, and then you could share it across files. So what we're going to do here is actually declare an app data struct. And inside of it, we want to put something in here that'll allow us to do our rendering. So all the rendering for Gunslinger has to keep threads in mind. And the way that you do that is you use something called a command buffer. So all of the, if we actually go to the graphics API, all of the runtime graphics operations require a command buffer. This command buffer acts as a sort of a virtual machine. So what it does is, as you're submitting submitting commands into it, it temporarily stores your data inside of the command buffer, which is just a byte stream. And then during the actual operation where it's going through and submitting all that to the GPU, it goes through the stream, looks at the information, grabs all of the operations, and then it submits them based on what the ops are. So we're going to create a command buffer inside of our app data, and that's all we'll hold there. And then we'll create a global instance of that, or we can create it just here. Let's make it global. Why not? So we'll actually create a an app data object, and we'll make that global. We'll just call it G data or app data. Okay. And then for our app, we can set our user data to that instance. All right. Now we're down here, we can grab that app data from the engine. There is a helper function, which is this user data, and you pass the type and it'll cast that void pointer for you. So we'll do engine user data app data. So now we grab that, and then we can start to initialize some of our members inside of that app data. So our command buffer, there's a command buffer new function. So we'll do that to initialize the command buffer. Okay. And now inside of our update, we can start using this command buffer in order to submit. So the first thing we could do is we could clear the screen. So we pass in our command buffer. Actually, before that, let's go over what the immediate mode kind of is. So the immediate mode is a way to be able to push raw verts back into buffers that are held inside of the immediate mode. And it's a way to be able to do like debug drawing, various things like that. So you could do lines, you could do text, you could do various shapes, primitives. And the way right now that you reach into stuff like that is that you use graphics immediate, grabs the immediate mode. Okay, and then everything that you want to do inside of an immediate mode, you'll wrap inside of this begin and end drawing function. And in the background, what this does is that this begin drawing sets a command to clear all the previous state that you would have had in between, and this end drawing is the final submit for all of our text data. Okay. And what we can do now is, let's just clear our screen, and we'll just set it to a red color. So now when we come through and build, first what we should do is cache our user data. So let's cache the user data up here. Let's just call it 80. So, okay. And then we can cache the command buffer because we're going to use it a lot. So let's just cache that. Okay. And now when we run, we should be clearing. Let's see, begin drawing. Okay. So one thing we didn't do, like I was saying before, is all that this stuff does here is it pushes commands back into the command buffer. The thing that's useful about this is that you could actually do this on separate threads, right? So typically with any kind of graphics drawing, especially in OpenGL or anything where you have to create a context between your CPU and the GPU, that is a one-way street and it has to be done on the main thread. If you want to do any kind of drawing or creating vertex buffers or any kind of graphics resources on a separate thread, then what you have to do is you have to have some way to be able to interoperate between those threads. So the reason why there's a command buffer system, someone asked me this in the Discord earlier, the reason why there's a command buffer system is because you can, on a separate thread, do all of these operations, queue up all these commands inside of this byte stream in the command buffer, and then you do your final submission to the command buffer on the main thread. And so all of your operations that you're expecting to happen will happen. Okay. Good morning, land. So right now what we're doing is we're just pushing back commands into this buffer, but we're not actually submitting anything. The final submit happens right here. This must be done on the main thread. Okay. So now when we go to render this, we should get our red screen, right? So now what we're doing is we're going through, looking through that command buffer, and we're clearing our screen. Okay. Now, like I said, let's actually get that to a not so obnoxious color. So let's do like a light or a dark gray. Okay. Now, the immediate mode has a lot of different functionality into it. I'm going to try and go over as much as possible in the time that I have. And see what we can create. I've got some previous code here off to the side just so I'm not going completely blind. Okay. So there's a few things we could do. You actually look in graphics.h and then you go up to the immediate mode or the immediate draw. There's all the different operations you can do. These will be commented and whatever else later on, documented a little better, just in kind of how to use them. But we can kind of look through here and we can see different functions. So let's try and draw a line. And what it expects is our command buffer, because we're pushing that back. We want a starting position, so we'll just go from 0, 0, so that's the top left of the screen. And then we'll go to, let's say, 300, 300. And we'll give it a color. If you go to types.h, where color is defined, there's actually a few default colors here that I've listed, so we can just grab one of these. So we'll just say a white color. Okay. Now we should have a line that's a single pixel, and it's drawn from top left corner to wherever we had it. We're 200, 200, something like that, 300, 300. Okay. And if we resize the screen, it's going to continue to do that top left corner. And then it just goes in screen pixels, right? So if the screen is smaller, it's going to go off the screen. All right. So one thing to note is that you didn't have to do anything with any matrices. You didn't have to set up, if you've looked at any of the previous streams where you had to set up uniforms in order to establish what your view matrix is, stuff like that. You don't have to do this in the immediate mode. The immediate mode in the back end is doing a lot of that for you, because the idea for this is to be able to do really simple stuff very quickly, and also fairly complex stuff fairly quickly, and try to make it as efficient as possible. So what this does in the back end is actually setting up something called a pipeline state. Okay, in this pipeline state, where is it? GS pipeline state. Yeah, this pipeline state has quite a bit that's declared inside of it. So it's basically anything, all the state that you need to push onto the GPU in order to do the kind of drawing that you want to do. So we have blend mode with the different blend mode types for the blend function. So the source and the destination blend mode types, the equation that you'd like to use, whether or not you want depth enabled, the winding order that you want to use, the face culling, which has different types, the viewport that you need to use, whether or not you're going to have a scissor for the viewport scissor, and then a shader. And then different stuff's going to get added later on, like depth stenciling, stuff like that. AVMA, ADENDI. So right now I'm just kind of going over immediate mode stuff I've been working on, how to use it, philosophy behind it. Okay, so that's a pipeline state. So whenever you begin drawing, what this does in the back end is that it pushes on a 2D pipeline state, so like a default pipeline state. And what that means is that you'll have an additive blend mode set. You'll have, so you can do transparency, basically anything that you would expect for 2D elements, right? So you won't have depth enabled. It'll be an orthographic view. And then it has a default shader that's set up. And that default shader is an MVP matrix, which gets multiplied through, and it has a texture that's associated with it. A dual sub. Okay. So hopefully this makes everything easier for you guys, anyone that's interested in using it. The idea is to make this as simple as possible, but again, to have that granularity still there, so you don't have to do any of this. You could do it the way that the other examples are done, right? So if we look at something like the simple texture, in here you're explicitly creating all this stuff, right? So all these graphics uniforms that you need, index buffer, vertex buffer, your texture, your camera, creating the shader here, setting up all this stuff, so shader, view, model, all that kind of stuff, setting up your vertex descriptors, pushing everything through. And then down here, binding everything explicitly, binding your textures, drawing indexed, and then submitting the command buffer, right? So it's kind of funny. This is a simple texture rendering, right? Level of granularity that I think I'm interested in providing in Gunslinger, because I think it abstracts all of the dirty work that goes on in the GPU. We're submitting commands to GPU, especially raw. It abstracts that away, puts it behind a unified graphics layer, platform layer, whatever. But it still adds you enough granularity to where you could do pretty much everything that you could do if you needed to do it by yourself. It just adds one layer above that, right? Now what the immediate mode does is that it takes that even further and it abstracts even more away, but it's still using those commands in the back end to basically set all that stuff up for you, right? It does, if you just want a 2D orthographic camera, just start drawing, and then start drawing your lines. That's basically the idea. There are other operations here. We could do like drawing rects, so let's go to that. Actually, I don't like this. I'm going to switch this out real quick. So x0, y0, Bear with me 1 second. Okay, and if I go to where this is defined, this is just to keep things consistent. That way you don't have to use the vec2s if you don't want to. So if we go back to our draw rect function, let's put that in here for reference. Again, we need our command buffer, and then we'll give it a screen position that we want to actually draw rect to. So let's say we'll start at 200, 200, and we'll go, that's the top left corner, and then we'll move that to 400, 400, and we'll give it just a red color. And we are not drawing. Let's see. 0. It's probably because I changed this mid-game. Oh, I know why. It's because I didn't actually. I changed Gunslinger. Let me build this real quick. Okay, there we go. Hey, Kristen. There we have our rect. Okay, so I think all this is kind of straightforward. This is stuff that you would typically expect. But we can go a little farther. Well, let's go over some of the more basic. Let's still go over some of the more basic stuff, right? So let's get rid of these. Like I was saying before, we can do various other things like pushing different states. Okay. Now there is one way to wrap, or I do wrap some states in a convenience wrapper. So what this begin 3D does is that it pushes on some matrices onto the stack. So in the immediate mode, I keep track of, for various states, the view projection matrix, as well as the model matrices that you want to use in order to multiply some of your verts through. And you can push those on direct if you want. Actually, if you go into here, you have all these different matrix operations. This works very similar to like OpenGL's immediate mode. So you can push these operations in, or you could push on a particular camera. So there is a push camera, which pushes on view projection matrices for you. Or you could do even further granularity abstraction and do something called Begin 3D or Begin 2D. So what Begin 3D does is that it actually creates a camera for you, gives it back to you, and then it pushes on to the stack the matrices for a default perspective camera. Begin 2D does the exact same way. Actually, Begin 2D gives you back the exact same camera that you're using by default whenever you call the begin drawing. Okay, so a lot of different ways to do the same stuff. So we can cache our camera there, and we can do stuff with it inside of here if we want to. Okay. Now, if we want to do like some 3D stuff, we could do like drawing like a box, for instance. So let's go to that. So it needs a vec3 for the origin, vec3 for the extents, which is, if you look at a box, what are its half width, half height, and half the depth dimensions. And then a color, we'll just give it a white. So let's do it, and this is world space positions, right? Because now we're in 3D. So let's give it an origin, and then we'll set it back -20 because our camera is at the origin, looking into the scene. And then we'll give it half extents of a unit all the way around. And there's a helper function for the vec3, which is _s for scalar, and it'll just set a uniform value for a scalar. So now if we draw this, we draw a box. Oh, it's immediate. Okay, so we get like a tiny little box there in the center of the screen. We can move it a little closer. Even closer, because it's a unit cube basically. So if we move it to here, it'll be fairly large on the screen. Okay. So this gives you an axis aligned bounding box. Hey Terrace. Right? So we have a 3D camera, we pushed on the matrices for that. We have a box that's at an origin. We're declaring a box at an origin of -2 in Z space with, it's a unit cube, right? So its dimensions are 1 by 1 by 1 because the half dimensions are 0.5. But what if you wanted to like move this box around, right? You didn't want it to just be here. Well, if you wanted to translate it, you could just define a different box at like a different space. So let's say that I just wanted to move it over the X. I could move it one dimension or one unit over in the X, and now it's shifted over, right? But that's kind of limiting because there's no way to rotate this, and there's no way to do full homogeneous transformations just using this, right? So there's no way to rotate it, there's no way to scale it, other than setting the half dimensions, and there's no way to translate it other than doing this. Basically what you're setting up here so take it you're done with Metal Slug 3. Moving on to the next project. No, actually this is part of that. So what I needed was more debug rendering, and I needed an easier way to do certain things. So this is in conjunction with that. I wish I had that work ethic. I think most people have that work ethic though. It's half start a project and then move on. So like I was saying, what you're doing here is you're basically declaring object space dimensions for this cube, right? So we are back at the origin. Okay, so if you say like you were to open up like a .obj file, you would have the cube that's basically defined in this way. You would have various vertices, and they would be, you know, centered like this. So let's define that. Okay, so now we don't see it because it's actually inside of the camera, because again the camera's at the origin. So, which is actually a couple ways we could solve that. We could push back this camera. We could like change the transform of the camera. Yeah, I'm not gonna do that, but you could change the position of this camera, we can move it around, you know, whatever. But what we want to do is be able to actually change the transform of the box, right? And what you can do in immediate mode is you can push and pop matrices like I was telling you earlier. So we're gonna do that now. So we're gonna push a model matrix. And then be sure to pop it when we're done. And we don't have to give it. Okay, and what this does is that, again, the immediate mode and the back end holds a stack of matrices, so it pushes on a new matrix that you're going to use to apply to all of the vertices that you have for this particular object. So now we could define a new transform. There's various different ways that we could use this. So we could call, again, let's look at the matrix operations. So all the different matrix operations that you have for any matrices that you push on. So if we wanted to, let's say, translate our object, then we could move it by some amount. Okay. So let's say we want to move it 1 unit to the right, and we want to move it -20 units in space. Okay. So there we go. So we moved it 1 unit to the right and -20 units back into space. Actually move it a little closer. There we go. So it's, again, if you'll notice, if you're watching before, this is kind of the same that we had with this, right? The exact same thing. It's just infinitely more powerful, because now we could declare at the origin a box that has a unit unit scale, but we can start multiplying these matrices through to actually start doing more useful things with it. Okay, one of those things being that, let's say that we wanted to move it by sine of our time or something like that, back and forth in the depth. And let's move it like, I don't know. Like that. Okay, so now we have a box that's oscillating back and forth. We could also rotate the object. And if we look at that, so there's different ways to rotate. We have rotate by floats, so you can give it some radian and then give it some axis that you want to rotate around. You can give it a vector, which does the exact same thing, or you can give it a quaternion. And this is my preferred method to do object rotation, so I'm going to use that. Use whatever you're comfortable with. And for the quaternion, I have an angle axis operation that you can use, and we're just going to rotate around the y-axis. So we're going to translate our object and then rotate, and so now as it's moving or translating, it's also rotating. And we'll put that back in the center. We could actually make this a little more crazy. And just rotate around 3 different axes. Okay. And what's cool about this is that, again, so we begin our 3D mode, we end our 3D mode, and then we can go back to drawing whatever. Right? So if we wanted to draw a line here, and go right back to our 2D rendering, and it shows up where you'd expect it to be. All right, so we also have in Gunslinger, now there's a way to do fonts. So you can load fonts up. So we're gonna add that into our app data. And then down in our initialization, we're gonna create a font. Which will cache our graphics. So for now, TTFs are really the only thing that's supported. OTFs will be planned in the future. But inside of the assets folder, we have this TTF font that I've stored in there. So we're gonna load that up, pass it to the graphics subsystem, and it will construct a font from file for us. So we have to pass it the file that we actually want to use, as well as the font point that you want to create the atlas at. Because what this does is that it passes it back to SDB true type, which that creates a bitmap atlas that we upload as a texture to the GPU. All right, so we have our font, and now we can start doing some drawing, right? So there's a draw text function. And what we have to pass back, again, like everything else, the command buffer. And then this is in screen space by default. So we'll do something at 100, 100. We'll give it the text that we're interested in. So let's just say, you know, test text, and then a pointer to the font, which is our data's font, and we'll give it a color. And data is undeclared, and it's AD. And there we go. Simple as that, right? Very little work to get the text up. So I think in the future I'll probably have like a default font that comes with it. All right. By the way, if anyone has any questions while I'm going through, feel free to ask. So all of this can also be, do you use C++ as well? I don't for this project, not for Gunslinger, but professionally, yes. My last game engine that I did personally, which I have videos on, was a C++ engine, but I prefer C. So there's also a way to handle VQSs. VQSs are really useful abstraction for doing object rotation, translation, basically any object manipulation. Why is that? I like how simple C is. Everything that you can do in C++, I can do in C. I don't like modern C++. I don't like the compiler doing things for me in the back end and hiding stuff. And C++ is pretty notorious for that. Hey, girl, May. It's all good, buddy. Let's see. So we can pass our VQS. So let's create a VQS. If we actually go into math, we can look and see what a VQS is for those of you who aren't familiar. It's just position, rotate, and scale. Some documentation here if you're interested. But for now, we're just going to pass up into this X form. We're going to create this stuff that we were creating before. So basically everything that we were doing here. Our rotation. Okay, so we've created our transform. Now we've just created that, we're not using it, so if we come back here and build and run, then our box is still being drawn at the origin, so it's kind of right in front of us. So what we have to do is we actually have to apply this matrix. So there's a mat mul VQS where you just pass back the transform that you want. And so there we go. Add some audio gain on OBS. Yeah, sure. Is that better? Just let me know if that's... I might have to turn the mic up. Let me see. How's that? I'm kind of messing with the mic right now. Is that better? Yeah, I think I can see that getting better. Okay. How about that, Uniday? Is that better? How did you get so good? I've been doing this for a while, about a decade. Cool, yeah. I'm not a boomer, but I'm definitely a boomer at heart, so. Awesome. This mic gets moved around a lot. So. All right, we're better. We're better. Let's see. Cool, awesome. Yeah, the immediate rendering is definitely going to work out. What does graphics stand for? So graphics is the graphics API that the engine has. So it's an engine subsystem. So I'm just caching a pointer to it here, right? Because you could do engine instance, which gets you the global instance of the engine, .context.graphics. That's just GFX. It's kind of a standard acronym. Call it whatever you want. We could call it graphics. You want to do that? Call it that. So I think in the future, people have talked about this in the Discord, but collapsing this so that this actually all just becomes this. And what the graphics subsystem actually does is that it stores all of this data instead of the immediate portion of it, which then that means that there's no separation between the standard way that you would do all the other operations and the immediate mode. What good books about graphics programming would you suggest? Immediate is implicit. Yeah, it does some implicit stuff for you. It's less explicit than the explicit operations that are typically provided with the graphics subsystem that I have. Good books about graphics programming? I don't know. Real-time rendering is a good one. So that might be one I would suggest. All right, let's do more stuff because this doesn't even scratch the surface of what's possible. So there's so for a lot of this stuff, there's only 2D element operations, but everything's stored in the back end as 3D positions. So what you could do, for instance, is that we're pushing a 3D mode and we could draw our text. And this puts it at 100, 100, 0 in world space. So what I expect to see now is nothing for the text, except for our transform, right? Because we've multiplied our transform through. So what we could do is go ahead and get out of that. So we won't be affected by this matrix. We'll draw our text, and now it's stuck at the front of the screen, right? So you don't see it there. And we could start pushing on a different matrix. And these braces aren't necessary. I just like doing it because it makes it more noticeable where the begin and end are. So we'll push and pop a matrix. Again, that's not doing anything right now. It's just putting on another matrix. You still won't see it until we start actually modifying that model matrix. So what we will do we'll make another VQS transform. I'm gonna do this, and I'm gonna show you guys some parenting of VQSs here in a little bit. I think we can get some cool effects with it. So we'll just make our text again back in world space. We'll put it back, and then we're gonna do another rotation on it. But for this, we'll do something like that. Okay, so what we're doing here is we're creating another transform. All right, we pushed on another model matrix, and we're updating its position. We're going to set it 20 units back in Z space, updating its rotation. So it's going to rotate along the Y, X, and Z axis with respect to time. Very similar to the way that our cube is. And we're going to scale down this text. Let's just do by 0.5, okay? And then we're going to draw our text. All right, so now we have the text that we used to have in 2D space is now being rotated around in 3D space. Which again, that's because of the way that this was placed, right? So we're inside of our 3D mode, which means that we have our 3D matrices pushed onto the stack. And now we have, you know, our text in the back. What we could actually do is get rid of the rotation. Okay, so now we have it in the back. So one thing I've noticed about the 3D text that I have right now, fairly certain it's a bug, just the way that I'm generating the vertices and applying the UVs, is that the text is actually flipped in 3D. So right now, a simple way to solve that is just to do a rotation along the x-axis. Flip it 180 degrees. Okay, now you're not going to see it, and the reason for this is that inside of 3D mode, we're actually doing face culling. So we're culling the back faces. And so this is something I thought about, right? So what happens is that this pushes on to the stack all of our state for a 3D mode, right? And this includes face culling. So right now we're culling the back faces. What we want to do is we want to keep all that state that we have, right? Like the shader that's bound, all the other state that's included, depth and all that kind of stuff. We just want to alter that one particular part of the state. So what I've provided is a way to handle that, which we can do push state attribute. And what this does is that you can give it any of the state attributes that's in the pipeline, and then you can affect that. And actually, I've got these listed up here. Let me move this closer to this. Okay, and this is actually a generic function. So if we go to push state attribute, you push in the type of the attribute that you want, and then it's a variadic function, so you just push in the data that you want for that. Sorry if I'm saying things that are not related to the stream, not really well educated, but I want to say that the Nuita video is really well made. Thanks, man, I appreciate it. Doing videos like that takes a lot of time, so people have asked, you know, when the next really produced video is coming out. I'm not sure. Is the 3D text taking depth into account? Yes. So it's basically rotating that quad in 3D space, and depth is enabled, so it'll pass behind the box and everything else in it, like you would expect. So we're going to push on a state attribute, and the thing that we're interested in is the face culling, and we just want to disable it momentarily. And then, like anything else, we'll pop the latest state attribute off the stack. Okay, so now when we go through and render this, we flipped the object, right? So we flipped our text, and now we're not culling any of the faces that we were before. And we can apply the rest of the rotations here. There we go. So now we have our 3D text just kind of rotating around in 3D space. And as you'll notice, as the box gets in front of it, it'll pass, you know, behind it, in front of it. So I think this is pretty cool. And again, we can affect the scale if it's too large. So we'll just lower the scale of the text. So now you could easily do 3D text in your scenes. Okay. So moving on. I talked about the VQSs and how they're useful in parenting objects together. Okay. So let's say that we had a requirement, or we wanted to be able to have like let's say it's like a debug view for our game, and we had like an entity ID, right? So let's say that that was the entity, and we wanted to be able to like view this for the object. All right. So it might be useful to have the text like floating above the object with respect to its transform. So let's try and do something like that. Let's try to have this text floating above the box. So what we'll do is we'll come up here, and we're going to try and parent or make our text a child transform of the box. So let's think about how we would actually like our local to look. All right, so what we want is in local space to our cube. If you imagine, hey GLDev, if you imagine for our cube, let's see if I have Photoshop up. I don't. Let me get paint up. Let me put in my I'm trying to make this really simple to use and beginner friendly stuff. I'm going to continue to make it a little easier than it is. All right, so let's say we got a cube like we have now. It's perfect. It's the best cube we've ever seen. And it's in world space, rotating around, but it also has its own object space, and it has its own parent space, right? So spaces are just matrices, it's just numbers. So if we want some text that's like sitting up here, right above it, right? So here's our text. We got to think about the local space that we want this text to be represented as, right? So in world space, it has a representation. It also has a representation in camera space. It has a representation in projected space. It has a representation in its own local object space as well, right? The text has a representation in child space too. And so we want to think about the child space. So if you think about how many units in child space that we want this thing to be above, let's say when this box is just axis aligned, right? So if we actually look at it as if it were like this, and it's at the origin for the X and Y axis, and we want our text up here, then we would do something like move it a couple units up just in the Y direction, right? So our unit space would be 0, 2, 0, translated above this thing. Okay. Then whenever we go to actually apply our final world matrix in order to draw this thing, we'll take this guy's matrix, apply it to the local matrix of this, and then it gives us out our final world representation. And so that's what we're going to do here. Now, using just matrices, this can be a pain in the ass. So what I've provided and what's kind of typical is to be able to use VQS transformations in order to be able to do complex matrix manipulations, right? So for this VQS local, we're going to say that our local position, again, we're just going to go a couple units above the box. Let's just say 1. We're going to rotate it locally in local space. We're going to rotate it 180 degrees around the x-axis. That way we flip our text. Again, this is just a bug for the rendering right now. We're going to locally scale our text down because in world space it's too large compared to what it actually is in screen space for the text. And then what we're going to do is use let's see, parent? No, it's absolutely, yeah. So there's 2 utility functions that are included inside of the math library, and that's the absolute transform for the VQS and the relative transform. So what you can do is you can give it a local transform and a parent that you want it to be respected to, and it'll give you back an absolute transform that takes these and it basically gives you back the product of those 2 things, right? It's more than the product, but that's basically what it's doing. Conversely, if you wanted the relative transform of something, say you have a world space representation of an object in VQS, and you want to see what its local space is going to be with respect to its parent, then what you could do is you could basically do what's the equivalent of a divide using a VQS transform, where it then gives you back the relative transform. So what we could do is use this. So it's GS VQS absolute transform, and we're going to give it the local and then our parent, which is our boxes transform that we have up here. Push state attributes, and what we will do, actually, this is going to cause an issue because we're still inside of its. So let's just call this box xform, local xform. Okay. Okay. That looks right. So we push on a particular model matrix for this box. That's good. And then for the text, we're going to push on a different matrix, which is our local xform. And it's going to be respected to the box xform. Assuming that I compile this correctly, let's see, 106. I think it's a small list that has an issue. Okay. GLDev asks, are all matrix multiplications quaternion operations in Gunslinger? No. No, they're not. So if we go to math, there are standard rotate, like matrix rotate. Oh, it's GS mat for rotate. So if you actually look at, there's a standard rotation matrix that you have, standard scale, standard translate, and then there's standard multiplications that you do. So there's a mat mul, yeah, right here. So you can do standard matrix multiplications. Right now they're 4x4 homogeneous matrices. I don't have any 3x3s just yet. Let's see. Uniday. I'm trying to convince my classmates to make a university project using Gunslinger. Cool. Just because of the new APIs, they're fantastic. Cool, man. Yeah. Hopefully they'll get easier and easier to use. 'Cause even this still is quite a bit, right? So I'll just continue to abstract these and make them easier. But again, what we should be able to do now, so that belt, so now our text is local to our object. Yeah, so it's above it. So this might actually be a little high. So let's say we're just a little bit above. And then our local scale, we can do even smaller. Looks like it's too small. Okay. And just playing with the local transform. So there we go. So now we have our box, and then we have the entity ID that's moving in relative relation to our cube. And again, if we don't make this as extreme, let's just say we'll just rotate around the y-axis for our box. But we're still moving in the z-axis. to, okay. There we go. So that looks right. So again, now we have 3D text. It's rotating with respect to the cube. All being done with the immediate mode. And then if we wanted to, let's say, do some yeah, sure. Let's just do like the world rotation of this object. And we'll throw that into our buffer. And we can print that out. So now there's the rotation information being dynamically updated and displayed. And it's quaternion, so the numbers are kind of confusing. So one thing I don't do is, or at least not yet, is do multi-line text. So I should add that. What if we wanted to add like 3D lines? So there is a utility for doing 3D lines. Okay, so you give it a 3D world position space, then a color. It'll give you a 3D line. But what's cool about this is that since we've pushed on this matrix model, what it's going to do is it's going to multiply the transform of this box by this unit line. And basically attach it to the box in 3D space. So now we can do axes, right? So we could do like draw the coordinate axes of the box. So we do green and then blue. So now we can do X, Y, and Z for the coordinate axes of the box. Okay. Another thing we can do is add textures. So we'll add that to our data, and then down here we'll need to construct the texture. So for textures, you have to provide a parameter description. Okay, and then you can give that to the graphic subsystem. And the reason you do this is that it actually caches that data and it gives it back to you. So all the texture data will be given back to you. So if you don't need to hold on to that description data, you can then free that data. Okay, so now we're loading our texture. So now what we could do is we could draw that texture. So there's a couple ways to do this. There is a draw rect textured. Where you give it a start position. So let's just use something at like 400, 400. Then you give it an end position. So this is the top left and the bottom right corners. Then the texture ID. So that's our texture ID in our data. Again, it's AD. And then the color that you actually want to multiply your texture through, so we'll just give it an orange color. There we go. So now we have our texture that's being drawn. Again, this thing will be respected in 3D space as well. So we could actually put it up here. And now it's probably inside of the cube somewhere. What if I put it down here? Oh, so it's down at the bottom. So if we pushed on a different matrix, let's say mat translate, and we'll just move it up by a couple units. Actually, if we just do that, so we make it a unit rect, and then we scale it. By 10 units. What does that give us? It's too small, maybe. Oh. Yeah, there it is. So there's our texture. So I think my 3D camera is upside down. I think that's the case. think that's a bug as well. I remember seeing that, BitSquid had a Sublime add-on to compile and run the game from the interface. Can you do that kind of add-on for Gunslinger? Yeah, you can. Actually, it probably uses VS Code. So you can make build scripts. You can make build scripts for Sublime. So you just point it to the bat file that you want it to run and then have it do something. So we can do something like that. I think it's fairly straightforward. So yeah, I wonder if it's because, yeah, the UVs need to be flipped. It's interesting. I'm gonna have to mess with the 3D. So we do that. Also, our box could be textured. So you just pass in a texture that you want it to do. What is it? Box textured. Oh, it's a VQS. Let's provide a different. We just need to do enable our texture and pass in our origin, our half extents, and our color. Drawbox textured. Then in OpenGL, we need to set this. Again, this is just a utility. I don't have to use this. But it just makes it convenient. And that's the point, is to add convenience for people. I think Drawbox disables texture, yeah. Right, because I'm not enabling, let's see if I do the Dropbox implementation. Yeah. Don't think that's correct. Tell you what, let's just do the BQS implementation. No, that's not right though. I want it to be Dropbox textured. I don't want apply. I want that to be object space. So I need that. Let's just see what that gives me. Okay. Now we have a textured cube. You can also do lines with thickness as well. Is it line ext? Now you get a line with thickness to it. And just to show that it is working, we could do should make a utility function for this. And again, this could all be done inside of 3D. So do 0 to 0.5, 0.5. Where is that? Yeah, there it is. But we're not inside of our attribute, so let's do that. Okay. You can also draw. You could do spheres. Spheres with lines. And we could do boxes with lines as well. So that requires a VQS, but I think what I'd rather do is do something like we have done before and just do this. And we'll make hold on. Draw box implementation, x is 0, origin. I just translate by the origin, but I should probably move the box. So the box definition should be that instead. Yeah, that should still give me the same thing. So I don't want to push a matrix. I don't want to do that. Because that means it invalidates any other matrices that I pushed through. This is fine because it's a convenience. So I don't mind that. Hey Dirty Mint, welcome. But for this I don't want to do that. This is expecting a unit box. Actually, again, just, oh no, I need lines. The lines are different. Yep. So push matrix, we will not disable. I think that is fine. QS, this is box implementation. Draw box lines. And for this, we actually want to stuff like this. Okay, and then the last place we need to go is GL, make sure that this is lined up. Okay, now we should be able to use it. So we have our textured box here. Let's draw a bounding box surrounding it. Which we can kind of cache our half extents in our box origin, and then we can just use it here. And we'll give it a white bounding box. Let's see what this gives us. Okay, so now we have a bounding box kind of surrounding this. Let's move our box a little closer. Instead of -5, we'll do -2. Now it's right on the edge, so what we could do is make our half extents a little bigger. We could do that. Just go by like a 1/10, maybe even larger. How big do we need to go? Say 5 pixels? This doesn't seem to be doing what I want. Yeah, it's not doing it. So let's look at, okay, because I'm not actually doing this. X.Y.Z. Same thing up here. Okay, I'm doing that. Good. That's fine. Okay. All right, so now we have a bigger bounding area. So let's just add, again, 0.5 to this. just a little bit to offset it. Yeah, 0.01 works fine. Okay, so now we have a bounding box. So let's say that this was a physics object, right? You wanted to show the bounding area. Let's see. Christian says, I have a render and a main thread plus a couple of worker threads, even though everyone has their own context with shared state. And the uploads happen completely async. The render thread stalls for a moment, even if the texture is never referenced. So are you saying that you have different threads that have different GPU contexts? Because that is going to stall the render. If that's happening async, it's going to stall the render. Because you only have a single bus to go between your CPU and the GPU. So if another thread is calling it, it's going to cause a stall until the GPU completes its work. This is why I recommend only have a single context and then do everything in this way, where you have like buffer up a bunch of commands and then just do it all in a single thread, like on your main thread, right? I'm gonna grab more coffee. I'll be right back. Does Gunslinger use immediate mode OpenGL or 3+? It uses whatever you want it to use. So right now I'm creating an immediate mode system that kind of sits on top, but what it does in the back is that if you're using 3+, then it's going to use that. Yeah, VMA's got it right. Actually, it's not even correct what I said to begin with. It's not going to support 1.1 to do some of this stuff because it's going to expect at least 3+, like 3.3. So what I'll need to do is extend this so that it works with lower stuff. So if you do this immediate mode stuff, it should actually call immediate mode GL. It doesn't do that currently. But the usefulness of this is that you can use immediate mode actions like this. Like this, to me, it's pretty simple. I mean, the smallest immediate mode rendering you could do is this, right? It's where you just clear the screen. Very simple. I mean, this is a full, and then the final submit. to the back end. But that's a full graphics program, you know. But then you can do some crazy, funky stuff as well. Like this. Let's make our text smaller. I'm just playing around right now, by the way, so. Good luck. Good luck with what? So as I use Gunslinger to do stuff, there's stuff like this that I would like to just wrap in utility functions just to make it a little simpler. Like the ability to be able to, if I could do this in a single action, right? So creating a temporary buffer as well as doing like an SN printf into it. So if I could do like SN printf C, give it the name, the size, do this. Like that would be useful. It would cut down, I think, a little bit on the code. I could do that. I think I'll do that. So we'll just define a utility here. And we'll just say name, size, format, and then our args. And we'll call, or we'll do character name, size, I think you can do that. And then GSSN printf, where we'll pass back the buffer. Yeah, we'll pass back the buffer, we'll pass back the size, pass back the format, and then the arguments. pretty sure that'll work. So then I should be able to do something like that. Yep. Ah. That still works. Peter asks, why C and not C++? I like C. I don't like C++. C++ does way too much for you in the back end. Modern C++ is a joke. Basically, I just don't need it. It's not even necessarily that, dev hedron. I mean, it can be. It's definitely simpler. I think so. That's the thing, is that people have it in their minds that C++ is simpler than C. I don't understand that. It's more verbose. And it just has certain idioms that come along with it, with the quote-unquote standard way of using it, that I just don't like. I don't like object-oriented programming. I don't see a necessity in defining class structures. I don't see a necessity in forcing object-oriented paradigms, like keeping certain things encapsulated, certain data encapsulated. If I want to do that, I'll do it myself. Just hide it inside of a source file. It's encapsulated, done. C++ has too many pluses. Yeah, sure. Well, I just like that the C standard hasn't changed, right? You just keep it simple. Again, there's nothing in C++ that I can't do in C. I've yet to see one thing. Also, I mean, keeping all of my, yeah, it is more simple, for sure. Keeping all of my interface files, right? So all my header files, keeping that in a C standard, or keeping it in strictly C, it makes the ABI simpler so that I can port this a lot easier. You can't do that in C++. If you write with modern C++ in your header, good luck porting it. And I have plans to be able to port this to Python, C#, D, whatever else anyone wants to use, even C++. Let's see, wouldn't structs be the same thing? Same thing as classes? No. So structs are defined as what's considered POD, or plain old data, meaning that there isn't any hidden offsets that are added to pad the struct, or hidden information that the compiler might throw in for a C++ class. So if you have a C++ class and you do anything that's outside of what's considered a strict C struct, it pads the data in a way that's not reliable anymore. And that's useless to me because I like to do stuff like in my byte buffer, where I have a generic read and write function so that I can just dump data streams into my byte buffer for serialization. In C++, I couldn't do that. If I had like a class with virtual, right? So if I had like some class thing inherits from another thing, so base, and then it has like public methods and it has a constructor. I'm already getting mad writing this, by the way. So it has like an f32x, whatever, stuff like this. I couldn't take my byte buffer and so the buffer, tell it what it is, and then the thing instance. I couldn't do something like this because this data isn't necessarily consistent. It's not guaranteed to be aligned in a particular way, right? Whereas if it's just a strict struct, f32x and y, I could do that because this is guaranteed to be aligned like that. Does that make sense? And also you can do inheritance in C, right? So let's say you had a base, I don't know, some base property of this, right? The way you do inheritance of C is you just include an instance of that thing. Done. And now any function that wants to take, so do something with base, take a pointer to a base, right, and do something with it. In another function, let's say your main, you can create it's called inst. You could do this by just casting to that. And it'll operate on that thing as if it were the base class. So you can do inheritance and polymorphism in C. Just the syntax isn't as hidden away from you. In fact, it's explicit, which I like. So I think what I wanted to do, again, I'm just playing around here, just testing out immediate mode stuff, kind of messing around. Make text to child transform. Yeah, you got me. So you can do a lot with C. Like I said, anything you can do in C++, you can do in C. Anything. You just have to be more explicit about it. People don't like C because it doesn't have a big standard library. In fact, its standard library is small and kind of sucks. So what you have to do is you have to write your own standard, which might not be the best case for most people. I don't mind it though. In fact, I like it. I like knowing what everything's doing. Came by to see, now I'm gonna leave. All right, later. What do you think about C#? Feels like C++ for newbies. I've used it. The studio I was at prior, we used Unity for one of the games we were making. It's fine. I mean, it's very similar to C++ in a way. It's like a weird mix between C++ and Java, I think. I switched from C++ to C, and it's so much simpler. Template errors can be hellish. Yeah, I good luck reading them. The only issue I have is with macros. So I do abuse macros, and you can't really detect macro errors. So you have to be careful with that. At least not easily. How does begin draw and end draw functions work? Do they set up a matrix for drawing? Yeah, so let's look at that real quick. Okay, so in the back end for OpenGL, all right, so this is the OpenGL implementation. I have all these opcodes. Again, it's like the command buffer is a big virtual machine, okay? So all these opcodes get written into, let me go into Paint. So maybe I should have Photoshop instead. All right, so whatever. So the way the command buffer works is, again, it's just a big byte buffer. And what it will do is at the beginning of the stream, it writes in a command, and then it writes in a big stream of data for that command. And then it just does this, it interleaves these, right? So again, after that, you'll have another command, and then whatever data is for that, okay? And these commands are the opcodes that are listed here. So if you want to bind a shader, for instance, then you call, let's see, graphics.h, you'll call graphics bind shader. It looks for this, it gives you this opcode, right? That is set to whatever the graphics implementation is, which is this function right here. So what it does is it pushes that command opcode into the byte buffer for your command buffer that you're using. It then writes out the program ID, so that's the data that it needs, and then it increments the commands, okay? And then whenever we go to submit the command buffer, what it does is it goes to the beginning of the command buffer, so it resets the byte buffer to the beginning, the read position, grabs the number of commands, and then just iterates through all the commands that's in the buffer. First thing it grabs is the opcode from the byte buffer, so it'll read that opcode, and then it has a big switch statement on what the opcode is. This is, again, this is virtual machine or bytecode interpreter, whatever you want to call it, 101. It's not even done that well. So our opcode, if we had our bind shader, it's this one here. So again, we read out the program ID, and then now we call bind shader, right? And if we go up to GS bind shader, it just calls GL use program on that ID, okay? Which this is what actually talks to the GPU. But again, this is done after you've done all this. This is reading through the command buffer, and it's finally calling all these. For the immediate mode, if we go to begin drawing, we have our immediate ops here. So what it does is internally, I actually have some immediate mode data. This immediate mode data is, if we go up here, immediate data, where is it? This guy here, it's immediate drawing data. So it holds some state. All right, so it'll have a currently bound state. There's a default texture that gets registered, uniforms that are used for this default shader, including a default texture and then a default model view matrix. It has a VBO, which is for all this vertex data that it submits, default texture ID, default color, text chord. Actually, this stuff here, this text ID, color, text chord, and stuff like that, these are actually the textures that are, this is the texture that's currently bound at the state that it's in, the color that it's going to be pushing up for each vertex, the text coordinate that's going to be pushed up, and then the current draw mode. And the draw mode is if you're in quads, if you're in lines, or if you're in triangles. Here's all the vertex data that gets passed, and then we have a bunch of stacks for all of our states, view projection matrix stack, we have a model matrix, viewports, and the different modes that you're in. So that's all held in the immediate mode, okay? In the future, what I plan to do, most likely, is drop the immediate mode and just have this be a part of the default graphics library, so that you could drop immediate mode rendering anywhere, and it'll keep track of stuff like this for you. It's kind of what I'm thinking. I'm not sure of a good way to do that. But anyway, if we go back to immediate drawing, so begin drawing. So what it does is we grab that internal data, and then we, at the beginning, we create a default pipeline state. And this is just an orthographic camera, view projection, and then some default blend modes, depth is disabled. It's what you would expect for a 2D. And then we push that state onto the stack. And then we bind, which includes our shader, by the way, it's a default shader. And then we bind our matrices that we want, so the view projection, whatever, bind our texture, which is a default texture, and then we push our op command. When we go to this op and the submit, which is down here, then what we're going to do is we're going to push this view matrix onto the stack, which is our default matrix that we had, and then we're going to set a certain state for our rendering that we need. So the text ID that we're using is currently the default texture, and our draw mode by default is going to be set to triangles. When you call end drawing, what you do is you do a final dump of all of the vertex data that's actually stored inside of the vertex buffer in this data. So it submits all of that. And then it clears all of the stacks and all the state. So in between there, it does all of that. And then there are certain things where it'll actually kick off render commands. So if you push on new state, then it's going to call a render command. If you pop state, it calls a render command. If you do any view projection matrix transforms, if you change that, it'll call a render command. And that's because that's stuff that has to get uploaded to the GPU, and so it has to affect the vertex buffer at that point. So that's kind of the basic overview of how the command buffer system works. But again, what's cool about this is I could have a command buffer on a separate thread, right? And then I could call these functions in the graphics subsystem in order to do drawing on a separate thread. And then all I have to do is sync up on the main thread and submit all of my command buffers, and they'll be drawn the way that I wanted them to. All right. Hopefully that answered your question. Ethan, did you just join? So I'm kind of going over, Ethan, I'm going over some of the immediate mode stuff. Yeah, of course, 30 minutes. You're learning OpenGL, okay. Yeah, so OpenGL is just a big state machine, and it's all global state. So if you wanted to do it can be tricky to keep track of, and you could very easily override state and lose where you are, stuff like that. So it's useful to do these kinds of layer abstractions on top of it so that you make that easier for yourself. Yeah, if you, Ethan, if you want to rewatch the stream later on, I'm kind of going over. I actually showed how to get to this point using the immediate mode stuff, starting from a fresh project. But what I want to do now is actually get some of this other information onto the box. Oh wait, I have that. Oh, there it is. So where the hell did that go? Okay, so let's, I don't need this in here. Oops. We'll do this. And then for the y-axis, so we'll do that. The other one will move out front. Let's do 0, 2f. And then we can do one just off to the side. Maybe? I don't know. That won't work. current clear. Got one down there, and then the other one's inside. So all right, so there's that one. Later, Ethan. Okay, so now that's out in front. Let's move our box back just to make it easier to see. Just hit 1 unit back. And then we can move. See, this is. Let's move this one out. Okay. Easy. And then we can raise all this up by making our font could be larger. So we could have larger font. Okay, I do have that. Make it a little smaller. Maybe not that small. Huh, that's interesting. It's actually gotten larger. That's weird. So there's an inverse with the radius. Huh, I have to figure that out. Let me look at. No. Oh, I do call it VQS. I don't want to do that. That's the reason why. So let's do draw a sphere. Let's just do a direct. So I just want a vec3 origin, f32 radius, and a color. And we're going to do all of this. So for implementation, but we will not be pushing matrices. And that's the implementation. Instead of this, no. Draw sphere line. Okay, let's just call them that. Let's just call. Okay, so now should be, yeah, so now 5, 1, draw sphere lines implementation, I'm not using it, okay. It's just gonna be a pain in the ass because I gotta multiply this radius through. Oh, man. 70 plus rings times I times radius. Should be radius squared. Or just, ooh, yeah, how does that? Let me try this. I don't think this is right. Radius of 1. Okay. I mean, yeah. That's about right, isn't it? I need to have hot reloading. 0.4 doesn't really quite give coverage. I think 0.5. It's still a little too far. It's like point. Yeah, that's whatever. I shouldn't do this either. There's another implementation. If we just did, instead of draw sphere lines, we just did draw sphere. Yeah, so this isn't correct. Let's go back to here. Let's make a draw sphere implementation. Just copy this. That should be all of this. not going to push matrices on. We're not going to disable a texture. And we need to multiply our radius through, just like before. Okay. So then for drawing a sphere, we just need to disable texture, and then we'll call the sphere implementation. Okay, now we have a non-textured full sphere. I need to add UV coordinates to the sphere, which is going to be a pain. And then we can put our lines back on. So actually we could do this, just offset it a little bit so there's no Z fighting. There we go. So yeah, so there's quite a bit you can do with this. I'm going to continue adding to it. And again, outside of this, we were 2D drawing. So let's just draw something. Let's grab like the window position. Or the window size, rather, from our main window. And let's make a buffer. We'll call it FPS text. And we'll just do 256 characters. And what should it be? Just FPS? Sure. Which I think I have that in platform. Frame, delta, render, update, previous. Don't I have a FPS? No? Alright. No, that's how you do it. Get the current frame time, which is in milliseconds, divided by 1,000. Or divide 1,000 by it. So let's draw our text. Okay, good. I did XY. And let's put the text at, I don't know, 1010 FPS. FPS is undeclared. Oh yeah, FPS text. I need the font. And full big. Let's do 30. All right, there we go. So, yeah, that's kind of a brief overview. I think what I might do is make a more structured video going over like Pong. So I think I'll make Pong using this. Just gonna show how to do that. Do one last thing. So we've got this guy, it's our parent X form. Pong would be great. Yeah, it's a great simple starting exercise, so I think I'll do that. And doing all the immediate mode drawing, it should be really easy. So let's make it like a planet. So let's have something that rotates around like a planet. Matrix model. Let's see. So this is drawing the box itself. We've got local transforms. Pops. So let's just do like a planet. So what we want to do you think you'll ever make videos like Nuita or ByteBuffer? Yeah, definitely. I've been looking for the next one. That's kind of what the Contra thing was I was just going to do a refresher on that, kind of go over that. But what I'd like to do, like Guillaume is working on an engine, and he's been interested in learning how to do like introspection. I might do a video on introspection and reflection generation. So that's something I might do. I don't know, I have a lot of ideas. It's just finding the time to do the videos, because the videos take a lot of effort to do, like the animations and the production and write the script and all that stuff. But yeah, I'd like to do another one. They get the most views anyway. They're the most popular, so. So let's do a planet. So right above our other guy, we'll just make it 0 to 0. And then our rotation, actually this is interesting. The videos were how I found out about you. Yeah, definitely. Yeah, the Noita video is definitely the most popular one. So I definitely plan on doing more of that. See, this actually isn't even correct. What I want to do is do, yeah, okay, this is what I want to do. So it needs to be cosine, sine, 32 radius. Let's do just 2, because I'm not sure how this is going to look. Actually, we can scale this by that. GS Vec3 scale. Okay, and it's cosine of, let's just do t. Oh, no, we want the parent. Okay. And then let's draw a sphere. And it's going to be a unit sphere, which honestly I should just make a draw unit sphere function, because that would probably be useful. Although, I mean, this isn't even, yeah, it's not even that. And let's do it like a purple color. Or red. Let's do red. That's the Vec3, not the orange. 121. BP's undeclared. All right, so there's my planet. It's pretty big. Push this out a little bit so I can see it. So it's interesting because it's respecting it's almost like if you wanted to do this, you would want to for the local, so we want to actually do something like this. PQS absolute is this guy. And then we want to pass in the absolute, but we want to set our rotation, our absolute rotation, to be just a default quaternion, I think. No, because it's not the rotations. Well, yeah, it is the rotation. Interesting. Yeah, because if I don't do that, yeah, shoot. But then you don't necessarily want it to rotate with respect to that, right? You don't even necessarily want to do that. You just want to grab the local position and then just add to that. So the transform, so this really could just be, I think I'm thinking about this too hard. So just add the, which is this. And then don't do that. Oh yeah, but I'm not even, oh yeah. Because that should be that, but then this should also. Yeah, it's something like that. Maybe not even the Y. Don't even add. So just do it around like a particular ring. So that's just going to go back and forth. Yeah, so you'd have to do it like on an orbital path. I'm not sure how to set this up. Maybe it's because it's on a different. These should all be the same. Yeah, that's why. That was exactly why. So there we go. So now it's on an actual orbital path. Huh. Yeah, so now it's respecting that, which I think, now that I'm looking at this, I could have done. This. GS Factory scale. Right, and then pass this in. That give me the same? No, because now it's respecting that rotation, but then I do absolute dot rotation GS quat default. So like the absolute rotation. Yeah, but then the position is still gonna respect. It's still gonna respect the transform of this guy. So it's not even necessarily what you want. You do want this. Because the way that the VQS transform works is that it's, yeah, let's get rid of that. it's fascinating, is that it's multiplying that rotation through, right? So it's messing with you. It's going to mess with the translation. So all right, I'll be right back. Can you guys hear me? If not, then I might have to end the stream. Oh, okay. So let's do local rotation. Okay. One last thing, just add a local rotation. Now they're all rotating around their own y-axis. All right, I think I'm gonna end the stream though. So, yeah, that's kind of a quick overview of some of the immediate mode stuff that's in here right now, and I'll continue adding to it. All right, see you guys later. Bye.